the derivative of Laplace Theorem 2, multiplication of f of t by t and t to the power of n. So let's write down the Laplace equation, which is Laplace f of t. That gives us the integral 0 to infinity e to the power minus st f of t dt. So that's the general equation, and that gives us a function of s. So if we now then multiply the Laplace f of t by t, so we get t that should give us minus the first derivative of function of s. The Laplace t times f of t can be written as the integral of 0 to infinity e to the power minus st t times f of t dt, and that should be integral of 0 to infinity. We write down the f of t first, and then the open bracket minus derivative of e to the power minus st with respect to s, and then close bracket t equal to minus d ds, this is the operator, bring it out, and then integral 0 to infinity f of t e to the power minus st dt. And that integral is basically minus derivative of f of s. An example of Laplace sine 2t. Okay, looking at the table on the right, we know that sine 2t is 2 over s squared plus 4. And let's now do Laplace of t sine 2t. And that should give us minus d ds of 2 over s squared plus 4. And the derivative of that is what I've done on the top left here. And that gave us minus 4s over s squared plus 4 all squared. But the minus multiplied by the minus of derivative, so you get the plus. Now let's do another example of t cos 3t, and that should be, so it's minus d over ds we're going to do, we know what cos 3t is on the table to the right, and we're going to differentiate that. And that differentiation is what I've done using quotient rule, because we're differentiating s over s squared minus 9. So that's quotient rule. So that's what I've used, and I got minus s squared plus 9 over s squared minus 9 squared, all squared. And if you multiply by the minus in front of the derivative, you get the plus. So you get s squared plus 9 over s squared minus 9. all squared. Let's do another example where we multiply the f of t by t squared. So f of t is cos 3t. In this case, we're going to split it up. So we do Laplace t of t cos 3t. We just done the t cos 3t. So again, we're just going to differentiate with respect to s. Once more again, t cos 3t. And we know what differential of t cos 3t is. S squared plus 9 over s squared minus 9 all squared. So we're going to differentiate that using quotient rule again. So that's how I've done it in the top left. And that will give minus 2s, s squared plus 27 over s squared minus 9 all cube. Multiply the minus by the minus in the differential, you get a plus. So, finally, in general, we can write that the Laplace of t to the power of n, f of t, is equal to minus 1 to the power of n, derivative to the power of n with respect to s to the power of n, f of s. So let's put that in a box because that is the general equation for multiplying f of t by t to the power of n.